For today, we're gonna be converting a decimal number into a binary number. So let's start. So decimal to binary. First, for example, you have 17 base 10, and you're gonna convert it into a decimal number, a binary number. So all you need to do is to divide it by 2. So starting off with 17 divided by 2, so the answer is 8, and then the remainder is 1. So always remember that you just have to use the whole number and then let the remainder be. There is no decimal point here. Then moving forward with 8 divided by 2, so that is 4, remainder 0, and then 4 divided by 2, the answer is 2, and again the remainder is 0. And then 2 divided by 2, that is 1, and the remainder is 0. And then lastly, 1 divided by 2, so the answer is 0, and then remainder 1. So how does it happen that it is remainder 1? It is because 1 divided by 2 cannot be na. So all you need to do is to copy this and then put it as a remainder. So all you need to do is to read it backwards, starting from the last digit, which is this one. This is the your last digit, last remainder, and then going to the first. So we have 1 0 0 0 1, and that is your binary number. Another example that I can give you is this. Let's say you have 99 base 10, or a decimal number, going to a binary number. So we have 99 divided by 2. The answer is 49, remainder 1. So, moving forward, 49 divided by 2. The answer is 24, remainder 1 again. And then 24 divided by 2, that is 12, remainder 0. And then you have 12 divided by 2, that is 6, remainder 0. 6 divided by 2, that is 3, remainder 0. 3 divided by 2, that is 1, remainder 1. And lastly, 1 divided by 2 is 0, and the remainder is 1. Again, all you need to read is the remainders, starting from the last digit. So the answer is 11000011. That is how you convert a decimal number to a binary number. Moving forward, let's try it vice versa. Let's start off with converting binary to decimal. So we have, let's say for example, we have 1001 base 2 to be converted into a decimal number. So there are two methods. Let's just call it the easy method and the easier method. So let's start with the easy method. So all you need to do is to write the number vertically, just like this. So we have 1, 1, 0, 1. And then you have to multiply it by the multiple of 2's, starting with 2 raised to 0, then 2 raised to 1, 2 raised to 2, and 2 raised to 3, and so on and so forth. Now, always remember that any number raised to 0 will always be equal to 1. So this is gonna be 1 times 1, the first one. And then the second one, 2 raised to 1, any number raised to 1 will always be equal to the base number. So that is 2. So that's going to be 1 times 2. Next, we have 2 raised to 2, that is equal to 4. So that's 0 times 4. And then, lastly, 2 raised to 3 is 2 times 2 times 2, that's equal to 8. So 1 times 8. Now, you have to get the product of each of this here. So first we have 1 times 1 is equals to 1. 1 times 2 is equals to 2. 0 times 4 is equals to 0. And then 1 times 8 is equals to 8. And then you have to get the sum. You have to get the sum of these products. So that's 8 plus 2 plus 1, that's 11. And this is gonna be your decimal number. So now, let's move forward with another example. Let's say you have 1101, 1101 base 2 to be converted into a decimal number. So, earlier we've used the easy method. This is the easy method. Now, let's go to the easier method. So, write the number as it is. So, we have 1101. And then, each number starting from the rightmost, this is the rightmost, write a number starting with number 1. So, if it is 1, there. And then, if you see that the the binary number is 0, this is 0, write the number at the bottom. So, 1, then multiplied by 2. So, this is 2. And then, we have 1 again. So, write it above. So, 2 times 2, that's 4. Times 2, that's 8. Now, you have to get the sum of these numbers at the top of the binary number. So, 8 plus 4 plus 1, that is equals to 13. This is already your decimal number. It is really easy, especially if you know how to do it. So again, this is the easy method and this is the easier. That will be all. Thank you.